Optimum efficiency is a key requirement for any combustion process. By ensuring the effective combustion of a given fuel, a well-tuned process will improve efficiency whilst reducing environmental impact and minimising the requirement for regular maintenance. In an ideal world, optimum combustion would be achieved when the air supplied is exactly matched to the amount needed to completely combust the fuel. Known as the stoichiometric combustion ratio, this air-to-fuel ratio would not supply sufficient oxygen to permit complete combustion in real life. The result would be unburned combustibles such as carbon monoxide, soot and smoke, escaping in the waste gases. As these combustibles will still retain unreleased potential chemical energy, the combustion process will be less than 100% efficient, and the risk of pollution would be increased. The answer is to use a supply of excess air to help ensure there is sufficient oxygen to completely combust the fuel. Achieving the right mix requires a careful balancing act to ensure the right amount of air is supplied at all times. Whilst too little air will produce unburned combustibles, too much air will reduce combustion efficiency, with heat being lost via the stack as hot flue gases. An ideal figure for excess oxygen is between 1 and 3%, depending on a range of factors, including the fuel being combusted, the steam load, and the condition of the boiler burner. One way of striking the right balance is by continuously monitoring levels of oxygen at key points in the combustion exhaust gas stream. By using a combustion analyzer to measure the amount of oxygen remaining after the combustion process, it's possible to fine-tune the air-to-fuel mix to help optimise efficiency. ABB's AZ Oxygen Analyzer sensors use zirconium oxide sensor technology, which produce a reading of the net oxygen remaining after the combustion of all the available combustible gases. The sensors consist of a thin piece of zirconium material. A supply of air is applied to one face of the sensor as a reference gas. The process gas being measured is applied to the opposite face. When the concentration of oxygen is equal on each side, migration of the oxygen ions through the zirconia is zero. When concentrations differ, migration of the oxygen ions will increase as they try to re-establish equilibrium. The reaction at the two electrodes will differ, generating a corresponding potential difference. Using an appropriate device, this difference can be measured to produce a percentage oxygen concentration reading. ABB's AZ analyzers can be used to measure efficiency at key points in the power generation process, including air preheater monitoring. By measuring and comparing excess oxygen levels at the entrance and exit of the air heater flue gas stream, ABB's AZ20 zirconium oxygen probes can help provide an accurate assessment of the performance and condition of air heater plant. The economizer outlet. The economizer outlet provides an ideal location for monitoring the levels of excess air in the boiler flue gases. ABB's AZ40 Oxygen and Combustibles Analyzer can be used to monitor both excess air and unburned fuel in the flue gases to help ensure the correct mix between the air and fuel in the combustion process. Flue gas desulfurization plant. Sulfur dioxide from flue gases is often removed by using it to produce sulfuric acid or gypsum for construction. Oxygen is used to help encourage the necessary reactions that need to take place. Using an AZ20 oxygen probe to accurately measure oxygen concentrations can help to regulate these reactions. Flue gas denitrification plant. Too much excess air can increase emissions of nitrogen oxides, such as nitric oxide and nitrogen dioxide. Using ABB's AZ20 oxygen probes to ensure the excess air level does not exceed the required limit can help to minimise the load on the flue gas denitrification plant. Stack CEM. ABB's AZ20 oxygen probes can be used as part of a continuous emissions monitoring or CEM system to ensure that emissions from the flue stack meet legal limits and as a means of checking the efficiency of the combustion process and any associated gas treatment processes. Find out more by viewing our separate AZ Analyzer animations.